Hello and welcome back to the lab. Today on the bench we have a HP, yes, the computer company Hewlett-Packard. They didn't start out that way. Model 201CR audio oscillator. So essentially what this is a 201C in a rack configuration. This piece of equipment is sized for a 19-inch rack space, and from the rub marks in the paint has spent a substantial amount of time in a 19-inch equipment rack. These are pretty nice oscillators. I use a 200 CD, which is a wider band version of essentially the same thing, on the bench quite often, actually, when I need a signal to just throw into something and say, hey, does this make a sine wave? The inputs to this thing are very durable, being that it is a vacuum tube-based piece of equipment. So it's kind of hard to, they can withstand some mistreatment before they go out, much more than a silicon function generator or something could be. So when I have some unknown signals that I need to just put some, when I have some unknown equipment that I need to just put some signal source into, having a just oscillator around the bench really helps out. This has been in storage for quite some time, has seen the worst wear, covered in dust, all kinds of good stuff. We can even see some dust on the knob. So we're going to get it all cleaned up, restore it. If it doesn't work, we're going to make it work, and we're going to get this moved on. I've had a technician ask me about this one already. He does some demos and things like that where having a good audio oscillator would be helpful to him. So going to see if we get this thing up and running, if he's interested in this one. So with that, let's get the case off. There's 2 screws in the back and these 2 screws in the front. This one holds some of the front panel into the case, so this one does not need to come out. It's these 2 and 2 in the back, and the back of the chassis slides off. This is back from a time when gear was made to be repaired. Power cord on this one is in good shape. Sometimes when we run into some of this older gear, the power cord is absolutely crusty. This one is not. This one's nice, supple. It's not cracking or doing anything weird, so we should be able to leave that one in place. Nope, I do not want to set it on its face. Where are we stuck? It's trying. Oh. Alright, I'm going to argue with this. And here we are. I haven't even disturbed the vintage dust yet. So quite a bit in there that we need to clean up. I do see some capacitors I want to replace, but I do also see some that get to stay. I believe this is the output transformer, so we have a pretty substantial output transformer on this thing. This is the power transformer. We have the attenuator up here, and then this is our shielded cable that goes to the rear signal leads. So on this one, we do have thermionic rectifications. So we have a 5Y3 rectifier, which means we're going to have to be a little careful with what we put in to replace this capacitor with. Too much capacitance on the other side of this tube can blow off the cathode bonding wires. Not necessarily a good idea. But we don't have silicon rectification, so we're going to have to limit it a little bit. Here's our light bulb. So I expect this probably uses the Wien oscillator circuit. This cap definitely needs to go. Not too much to do in here other than clean it up. Big tuning capacitor down here. Nice. Actually, that moves really nice. Not even jammed up. That's great. A little bit of oil on this mechanism, and that's going to be fine. Nice big tuning cap. I do sometimes wish this was feel-o-vision, because this is moving quite well for its age. Usually these controls are bound up, jammed up, and they take some getting going, but this is moving quite well. And this is also on this side is quite clean. So that is going to be pretty stout. Check the resistance on this resistor. That looks like it may have gotten hot at some point in time. Nice heavy shielded cable between the front and rear outputs to keep the noise down, as to be expected with HP test equipment. We are going to service up all these controls, get them cleaned and lubricated again, but they're actually not moving terribly bad, so everything looks pretty good so far. Hopefully it works. Haven't even plugged this in yet, so we will figure that out together. First order of business is we're going to get this cap, this black beauty replaced, and the other capacitor and the filter capacitor replaced on the other side. Then we'll give it a power up and see if we have what we expect on the scope. All right, we've got the unit to where we can test it. It is not finished yet because I have a capacitor that's in circuit that's very, very borderline and isn't going to run very well. I have not cleaned anything yet. I haven't cleaned the switches, anything like that, done anything. All I've done is replace the electrolytics. I did also, and I'll get the schematic out here in a second, I did also get a, I checked the ripple on the main filter can, which is a 20 microfarad on the back of the 5Y3. And the B plus was low, and the ripple was 5 volts AC in terms of ripple. That's way too high, pretty much for any HP power supply. But so this can was toast. We did move some capacitors around. I've got most of them on this side of the board now, so they're closer to the loads. And we're ready to give the unit a test. I have the frequency dial set at 100 kilohertz. And we have 0 dB of attenuation. And I'm going to move you guys up to the scope. Okay, we'll see if there's any smoke. Hopefully not. I'm pretty sure we got the caps in the circuit the right way. And we shall go from here. Tubes are lighting up. Okay, the light bulb glowed a bit, so that's a little strange. Let's see what happens if we give it some signal. Well, that doesn't look right. Okay, so as always, I'm going to triple check the work. I triple checked it before I turned it on, but I'm going to triple check it again because I'm going to assume I haven't wired something correctly and go from there. This is a little strange, but we'll take a look at it when we get back. Okay, here's the work we've done on the top of the chassis. Going to get a plastic pointer because this was on. I don't want anything conductive because this probably still has some spicy voltages running around. If you're going to work on gear like this, know the hazards. Anything that has tubes in it is going to have very elevated voltages. Actually, that's one of the parts I have to order to finish this up. The B plus in this unit, at least at the main filter, is before, well, surge voltage is 420 volts. Resting voltage or working voltage is about 320. So there's a lot of high voltage going on in here. So we've got our 40 microfarad caps. These are 500 volt caps. They're totally fine. And we have our 22 microfarad by 450. This was my last 22 by 450, so I have to wait on the mailman to get the other one for the B plus supply. This is a bypassing cap for the oscillator tubes. This is all set up right. So this is all wired right, and everything's good to go. So that's not going to be our problem. We know the caps are in circuit correctly. They're not venting or exploding, so they're not getting energetic. So that's not going to be our problem. So everything looks like it's okay. This is the can that came out. Everything that is grounded is supposed to be grounded. Everything that's not supposed to be grounded is not supposed to be grounded. This cap and this cap are ground referenced. This cap is not ground referenced for anybody who wants to take on a restoration like this. So, was this work necessary? Absolutely. We know for a fact this cap was toast. This cap wasn't far behind. So these do need to get replaced. One thing that I did notice is we don't have a correct voltage on the negative side of this capacitor. Now that points to something in the wean bridge being messed up. This section right here is essentially the oscillator section tuned by the slicer cap up top. So I want to focus my attention to this lamp because this is one of the hearts of the wean bridge. Actually, if this lamp opens, nothing in the circuit works. It just kind of oscillation dies. And I did notice that this was glowing a little bit when the unit was warming up. In fact, we'll turn it on right now so you guys can see what's going on. Okay, that's actually glowing fairly brightly in the camera, and it's actually glowing fairly brightly in person. Typically, wean bridge oscillators, which this is, should not glow the bulb. This is a dynamic resistance that's in the oscillator that is making it actually a very low distortion sine wave. We have a bunch of ringing on the output. This is just all kinds of terrible. So I'm going to take a really... Oh, wow. Hang on a second. The unit is on and the scope is triggering. We have all this ringing down here. We have this weird notch here, flat topping here. Not a sine wave. Pretty much looks horrible. So I'm just going to take my plastic tool and I'm going to lightly tap the light bulb. And I'm also seeing the current fall off. I think that filament in that light bulb has collapsed and is not looking too healthy. So I think our problem may be the bulb. I do not think this is going to show up very well on camera, but this bulb is a tangled mess of filament down at the bottom. The filament should be up here on the supports, and it's fallen to the bottom of the bulb, so the filament's collapsed in this lamp. That is definitely going to affect our oscillator and make it so it doesn't quite work correctly. So let's see what the lab has for a replacement bulb and see if that makes a difference. Okay, I have found this bulb, which I think will fit the bill. It is a 120 volt, 6 watt light bulb. The wattage of a light bulb in one of these wean bridge oscillators is actually pretty critical. If you put the wrong wattage in, it won't work, won't oscillate right, all kinds of weird stuff will happen because of the dynamic resistance of the filament heating up and the way it functions in the wean circuit. So you can't just throw any old bulb in this and expect it to work right. So we're starting. I know the bulb that shipped with this is a 6 watt bulb. We have a 6 watt bulb. And so we're going to see what happens. The base on this, if you need to replace one, it is an Edison style candelabra base, as far as I can tell. They don't actually give you a model or part number of what the bulb is. They just say, oh, 10 watts. But it wasn't even 10 watts. It was 6 watts in some of the other documentation that I found. So it's not really consistent on there. So we'll see what we can make happen. Because we have replaced the bulb, we are going to have to adjust this potentiometer. So we'll see what it gives us. It may give us some junk, and we have to do that. You do that by measuring a voltage node down here and then adjusting the negative side of this capacitor to chassis and adjusting for, I think it's 20 millivolts AC, if I remember the documentation correctly. However, given that we have replaced the lamp in here, and the old lamp is faulty for sure, we're going to have to do a full alignment on this unit before we get it to its final technician. All right, I have you guys watching the scope again. We're going to hit this thing. I'm drawing about 60 watts, which is kind of normal for this unit. And let's see what we get. Well, that looks better. I'm happy with that. Yeah, I'm stoked that it was just a bulb problem. So What I'm going to do is just to kind of test the repair, make sure the unit's not having any heating problems. I'm going to put the chassis back on it, and we're going to let it do some burn-in testing tomorrow. It's getting a little late here in the lab today. Tomorrow we'll let it run all day. That cap that's marginal, we're not shipping it with it, but it's in there enough where we can actually do some testing. It will be fine for a burn-in test due to the fact that it's the running voltage is about 320 and it's a 400 volt cap, so the surge is 420. That's why I want to get a 450 to put in there. I just don't have any on hand at the moment. But we'll let it do some burn-in testing tomorrow, make sure it doesn't have any problems, and then clean up the switches, lube the mechanics, do an alignment. It's probably going to be ready to go again. And we have a capacitor delivery already stocked up. 22 microfarad, 450 volt caps for the B+ supply in this oscillator. Okay, I have the unit ready to turn on. The new 450 volt cap is in place, and we're going to take a look at why this was such a big deal. So I'm going to fire up the oscillator now. It's on, and we see the rectifier tube has kicked in already, and we're at 420 volts, 420 volts. So that's a little much for this 400 volt cap. Over time, that would beat it up, and it would fail prematurely. As we can see, the voltage is falling. The other tubes are coming into emission and dragging the power supply down. So it was fine to run there, but every time you started the oscillator up, it just surged that cap. So it was not long for this world. It would have held on for probably a while, but it wouldn't have been where we'd want it to be. I've got about 25 volts headroom, so I am totally okay with that. 327 on a 450 volt cap. It's going to live there for quite some time. So, got to clean the tubes off, get all the dust off the tubes, and then we're into doing an alignment. I do not know how well this is going to show up in the camera, but judging by the getter on these tubes, this unit has some time left on it, but it has been on for quite some time. That is not shiny. That is not shiny and silver anymore. That is starting to become a dull kind of chocolate brown, but it's still more chrome than brown. So the tubes are aging, but they're not aged out yet. Obviously, the unit is still functioning fantastically, given our testing. But these tubes have been on for quite some time. Why don't we throw this one in a tube tester and just kind of see what the life is left. Okay, we'll press into service the Stark tube tester that we repaired in a previous video. I don't show a lot of tube testing on the channel because there is nothing more boring than watching a guy go through and test a bunch of tubes. And I say that as the guy who is going through and testing a bunch of tubes. So that's kind of why I don't show a lot of this, but we'll give this 6K6 a shot and see what it says. So the first things first, we're going to check the line adjust, and that's okay. We're going to do it again once the tube's in place. Filament voltage is set to 6.3, which it is. We are at JR. 5, 3, 4, 7, 0. Bias is going to be 34. English is going to be 67. And that sets us up to do a mutual conductance test. So we will pop the tube in. Always set the filament voltage before putting the tube in the tester, because you can blow the tube up, you can burn the tester out. Always set filament voltage before inserting tube. It's also a good idea to set the selectors too, but definitely the filament voltage. Okay, we've got some glow on the tube happening. We're going to do a line test again, and we're a little low. So we're going to bump up the line current to get it right in the middle, which is right there. Now, what we're going to do is we're going to test this tube for shorts. So we take the shorts knob, roll it all the way back in, and if this glows after setting, it's a faulted tube and needs to be replaced. If you don't test for shorts and you just go right into doing a GM test, you can actually damage the tester. So this is a very important test. So 1's good, 2's okay, 3, 4, 5. The flash when changing is normal. If it stayed glowing, that would be a problem. So we're looking for a mutual conductance of 1600 on this 6K6. So we should be above the center. That was a very healthy tube. So using the English scale, which we used the replace good. We're looking for a 1600 mutual conductance, so if I go to 3000, we'll be on the top scale, so it'll be right above center. So we're having a mutual conductance of 23-ish hundred. So very good, healthy tube, and has plenty of life left. We can even do a life test, so we'll hit GM. Yeah, this tube's fine. So high hour tube based on the getter, but still perfectly acceptable. Okay, we have to wait for this to come up to temperature and let everything happen. All the controls are on the bottom. Yeah, we can get to it if we flip it the right way, so let's flip it over. I am nowhere near grabbing this, and I'm very comfortable working around high voltage. Also, working around the camera makes this difficult. But if you're not sure, take care and do not duplicate what I am doing on camera. Okay, for the alignment, I have talked to the person who is going to be the owner of this, and they're okay with a little bit more drive. There's two things. There's R10, which I cannot actually bring the voltage low enough due to the fact that we don't have the correct lamp. But they're okay with more drive and a little more distortion. So the distortion is still in the 0.1 range, but where I should have about 40 volts of drive, I have about 70 volts of drive. So we have a lot more drive, and it will distort, so it'll push the oscillator into distortion. Given the demonstrations that he's going to be doing, that's actually okay. But we do need to get the frequency on point. So we're on 10x 20, so 200 hertz. And we're at 191, or so says the Rigel. So we're going to adjust for 200. And we'll use the scope counter up here, because that'll have plenty of frequency for, or plenty of accuracy for this adjustment. You guys keep an eye on that and let me know when we've hit it. I did need to adjust the dial a little bit for getting this to track correctly. So here's our 2000 kilohertz, so 2 kilohertz. We're at 2001. And here's our 20. Right there. 199.7. So I'm actually not on the 20 there. I'm on the 20 now. Hey, look, 200 hertz. All right. So our dial tracking is now in good shape. Okay, let's check some distortion specs. We're going to bring it up, not to the 1 watt range, and we'll let this settle. And the distortion's running at 0.3. It's supposed to be below 0.5%, which we are, and that's good. Bring it up to the 3 watt range, and we should be below 1%. And we can distort when it's that high, but bring it down a little bit, and we're at 0.6%. So the distortion output on this particular unit is in very good shape. The output amplitude and the distortion are very, very sensitive to the lamp, and given the fact that we had a bum lamp, we do not have the factory HP specified lamp anymore. So some of this we're having to work with what we have, but it's not worth giving up on the oscillator because it's still a wonderful instrument. Thanks for stopping by the lab and taking a look at this piece of HP history, the 201C audio oscillator. If you would like some more content and some early access, take a look at the Patreon page. All videos that end up on Patreon will end up on YouTube at some point, at least for now, as of the recording of this video, but they are running ahead on the releases. Their donations help keep videos coming, keep the lights on here in the lab, and stuff coming up for the channel, and their help is greatly appreciated. More than probably anybody ever knows. So for those that are assisting in the lab and making these videos come out, as always, thank you for your support. For everybody else, I hope you enjoyed the video. As always, more's on the way, and I look forward to talking with everybody in the comment section below. In between videos, I do read all the comments, and comments will sometimes spawn videos. So, with that, I will see everybody in the next video.